Hello, I'm Kaustubh Kulkarni, and my dissertation project is the analysis of electric vehicle charging stations usage and environmental sustainability in the UK. So, my dissertation presents an in depth analysis of EV charging stations usage across three geographical levels. So, for the country level, the analysis is based on Scotland, and for regional level, the analysis is carried out for London Borough of Barnet. And on institutional level, the analysis is carried out for Newcastle University's Urban Science Building. So I've extracted the data from public sources, and based on that, I have identified some key trends and have identified the factors which might affect the charging sessions. So, first of all, and my dissertation tries to answer these three research questions. So, first is how can data science help the primary objective of improving the EV grid infrastructure? Second is what are the past and current situations and trends of EV charging patterns? And last is what is the relation between the energy consumption of EV charging stations and the carbon emissions? So, in this project, I have followed the CRISP DM methodology. This is a data science life cycle which performs 6 steps to carry out the data analysis. So, in the first step, I have understood the problem from a business perspective and how data science can help solve this problem. And in the second step, I have understood the data by in depth. And for this, the first step is the collection of data. I have collected it from public sources like ChargePlace Scotland and Open Barnet for Scotland and London data, respectively. And I've collected the data of urban science building from Fastnet, and the carbon intensity data was extracted from carbon intensity API for each region, respectively. So in the data, there were four basic variables: the charging start and end time, the charge point ID, which is the ID of the charger, and the energy consumption in kilowatt hour. And for the carbon intensity data, the data had date and time, and also the carbon intensity level. So next, I have created a data quality report for each data set and identified some null values and also some anomalies in the data in each data, and also have suggested some addressing suggested some steps to address the null values. So next, I have prepared the data by calculating some new variables and features, and I've calculated the charging duration based on the end time and start time of the charging. And next, I have calculated the carbon emissions, which is the carbon intensity multiplied by the energy consumption at that time. And next, I have calculated the time based utilization rate, which depends on the duration of the charging divided by the total 24 hours and the number of days into 100. Further, I have extracted the hour, day, and the month, and also I have assigned the season for each event to carry out my further seasonal analysis. So for London data, there were no charger connector types. So I have assigned the charger connectors based on groups, based on the energy consumption levels. So our next step is the exploratory data analysis, and this data analysis was carried out in four ways: the statistical analysis, seasonal analysis, weekly analysis, and hourly analysis. So let's start each analysis by each region. So first, for Scotland, the total number of sessions were 2.75 millions, and there were 3,538 charge point IDs. And for that, as we can see in the table here, the ultra rapid and rapid chargers are the DC chargers with most of the number of sessions and also high energy consumption rates, and which also have contributed to higher carbon emissions compared to that of AC chargers. So this is an overall graph of the sessions carried out in Scotland. So as we can see, there is an initial spike in the winters, and as we go forward to summer, the emissions are lowered, and so does the car, and so does the energy consumption. So next here is the average energy consumption for each month, which does not so much of a variation, but we can see here there is a more increase in the winter of 2023, and as we can see, the average amount spent for each sessions in each month has also increased variably, and the time-based utilization rate we can see here is more in winters rather than all other seasons. So this was for the AC chargers, and if we look at the DC chargers, we kind of find a similar trend which shows there is spikes for each of the parameters in winter season. So this is the weekly analysis of energy consumption based on weekend versus weekdays, and which is also associated with the carbon emissions. So we can see that the values in the weekends are much higher than that of the weekdays in winter season, in and so does the trend follows for each of the DC chargers. But if we look at the AC chargers, the levels are greater in the weekdays rather than that of weekends. So for seasonal analysis of AC chargers, we can see that there is not much of a variation, but we can see there are more values in the winters, and also the carbon emissions follow the same trend. And if you look at the time-based utilization rate, this also follows a quite similar trend compared to that of energy consumption, which where we can see there are slight greater values in the winter season. If we look at the DC chargers, we can see a quite similar trend, but we can see a spike in the October month of 2023 in energy consumption. And if we look at the time based utilization rate, the time based utilization rate is much lower in 2023 summer and has increased as we go further. And this is the hourly analysis of energy consumption and carbon emissions for Scotland. So if we look at this, so we can see that the energy consumption, hourly energy consumption for ultra rapid chargers is much higher than any of the chargers. It it might be because of the high speed of the chargers that it provides, and if we see there is more energy consumption in the early morning hours in for each of the chargers. So there is a missing gap here in AC controller, which might also suggest that no one has charged in this period of time. So this was for the Scotland data analysis, and we will move on further for the London analysis. So if we look at the London data, there are total 6,225 sessions of charging sessions for 72 different distinct charge point IDs. And as I've said earlier, the energy consumption groups were allocated based on the energy consumption levels. And if we analyze the overview of this data charging sessions, we can see the energy consumption is variably increasing after in each year after each month, and the similar trend is kind of followed by the carbon emissions. But if we look here closely, that after 2020 there is a great spike in the energy consumption, which was also the post COVID period, which might also suggest the impact of COVID on the usage of charging stations. Okay, so if you look the carbon emissions analysis for each season, so we can see that the values of energy consumption are more in the winter months compared to that of summers, and also the carbon emissions kind of follow the same trend with it. And if we look at the time based utilization rate, this also follows the same trend where we can see the values for winter in winter month are more compared to that of summer month, sorry, summer season. So if you look at the weekly analysis, so we can see that the for energy consumption for group 1 charger is quite is slight more in the weekdays compared to that of weekends. Same trend is kind of followed by the group 2 chargers, but if you look at group 3 chargers and 4 group 3 and 4 chargers, the energy consumption is more in the weekends compared to that of weekdays. And if you look at the hourly analysis of energy consumption and carbon emissions, so we can see that group 2 chargers have shown a spike in the early morning hours, and if we look at the group 4 chargers, there is a spike in the in late evenings, and if we look at group 3 chargers, the energy consumption is high in the late night chargings. And also if we look at group 1 charging sessions, so the energy consumption is more in the early morning sessions. So all four of the groups show variable charging sessions, energy consumption graphs. But if we see the carbon emissions follow kind of similar trend with the energy consumption on hourly basis. So this was for the London Borough of Barnet, and we move on to our last data, which is the urban science building data in Newcastle University. So this data covered approximately 29.77 case sessions with six different chargers, and which had three types of connectors: CHAdeMO, IEC-T2 Type 2 connector, and also combo connector. So if we see, combo connector has the highest average energy consumption, and also the number of sessions are more of the combo connectors, which might suggest its its frequent use and its popularity. So if we look at the overall energy consumption for urban science building charging station, we can see that the energy consumption is increasing in each month, but we have seen a downfall in the last month in July 2024. And if we look at the carbon emissions, they follow a kind of opposite trend. Like the carbon emissions were the highest in the early year 2021, but it can be seen decreasing over the years. So if we look at the carbon emission analysis, so I've done the analysis for each type of connector. So we can see here for CHAdeMO, which is strictly used for Nissan vehicles, has seen some lower values of energy consumptions with a maximum of 16.95 kilowatt hour, and the energy consumption values are highest in the winter and spring season compared to that of summer season. And the carbon emission also have seen higher values in winter seasons of all these years. A kind of a similar trend is followed by the time based utilization rates, where winter and spring taking the lead in values compared to that of summer season. So if we look for the type 2 connector, it kind of follows a different trend than that of CHAdeMO. The spikes are seen in the summer and autumn season compared to that of winter season. The values are lower, and the maximum peak reached by the type 2 connector was 23.51 kilowatt hour in the initial months of 2021. Same similar kind of trend is followed by the time-based utilization with higher values in the summer season compared to that of winter. And if you look at the combo connector, the energy consumption values are much higher with a peak of 35.58 kilowatt hour in the month of December 2022. And the time-based utilization reached a peak in 2021 in the November month of 2021. So if we closely analyze, there is not much variation in the values, but the energy consumption is higher in winter. Also, the carbon emissions align with the energy consumption. So if we look at the weekly analysis of energy consumption, so we can see that for CHAdeMO connector, the values are higher on weekends compared to that of weekday. And if we look at the T2 connector, the values are higher in weekdays compared to that of weekends. And combo connector kind of follows the same trend like CHAdeMO with higher values on weekend compared to that of weekdays. And if we look at the carbon emissions are lower during the weekend compared to that of weekdays. If you look at the hourly analysis of energy consumption with carbon emissions for CHAdeMO connector, the energy consumption follows a quite similar trend. But if we see, the values are quite high in the early morning sessions with reaching a peak of 19 kilowatt hour. And also the similar kind of trend is followed by the carbon emissions. If we look at the type 2 connector has reached a peak at 28 kilowatt hour in the early morning, but has also have seen a peak in the late night. And the same kind of trend is followed by the carbon emissions. And if you look at the combo connector has reached a peak of 37 kilowatt hour in the early morning sessions and have seen a constant energy consumption values throughout the day. And similar kind of trend is followed by the carbon emissions. So overall it can be seen that the carbon emissions follow kind of similar trend with the energy consumption, which might prove a with positive relation between carbon emissions and energy consumption. And also uh, highest energy peaks were achieved in the winter season and increased activity on weekends, and there is a notable rise in charging sessions during late night hours in the and early morning hours. And also we examined the seasonal analysis monthly analysis in which we saw that in the post covid period the energy consumption and carbon emissions have risen dramatically. So these so all this analysis carried out for these three geographical levels has completed our research, have successfully answered to our research questions. And based on this, these analysis can help in improving the EV infrastructure and taking some significant decisions. Thank you.